Let's talk about another type of flow control known as looping, which allows you to perform repetitive tasks. So let's say we want to determine the absolute value, but instead of the absolute value of a scalar as we did previously, we want to determine the absolute value of each element of a vector. So let's say we have a vector of random numbers that we create with R norm. So for example, n is equal to 3, and we will have a vector of 3 numbers, and we would like to compute the absolute value of each of these elements. So we could have a vector for absolute values whose first element would be the absolute value of the first element of rvec, and if it is greater than 0, then we just return rvec 1, else we return -1 times rvec 1. And now I could copy and paste this code for the second element and the third element as well. Of course, I would have to go and change the indices in this. And I'm changing the indices, and you can already see how cumbersome this is. And we run into a problem where R complains that this absr variable has not been found. Normally, when we use an assignment operator, the statement on the right tells R what type of variable to create. So for example, here R knows that R norm is going to return a vector of a certain length, and so it creates a vector of a certain length rvec and assigns this the values of the returned vector from R norm to rvec. However, in this case, the statement on the right does not will return a scalar, but we are asking to assign that scalar to the first element of a vector that doesn't exist. So R is complaining about not finding this vector. And this is an important aspect when we want to perform such repetitive tasks with vectors. We need to create absr before we start populating it with values, and this thing is known as initialization. And the way I can initialize a vector is with the function vector. So the function vector returns empty vector, and it has an argument called mode, which tells it what is the data type of this atomic vector, because all the elements will have the same data type. In this case, we want something that's numeric because we're going to be populating it with numbers, and then you give it a length. So we will give it a length, and now hopefully R is not going to complain. And we run this code, you can see it's working, and the negative value has been converted to positive, whereas positives have been retained as positive. So this is working, and the only thing we had to do here that was unusual was we first had to initialize this vector. However, this code has, or this way of performing this repetitive task has a lot of weaknesses. First, this code is not general. What if the length of the vector were to change? Then I would have to change the number of times I repeat this code. And this code is quite impractical because you saw how it is cumbersome even to cut and paste the code 3 times and modify it with the indices. But imagine having some data set, for example, the flights data set, which has hundreds of thousands of rows. It's simply not practical to cut and paste the code hundreds of thousands of times and modify the indices each time. And then even if we decided to do it, this is problematic, because there's a big chance that, for example, I forgot to change the index over here. I changed it to 3 and in the condition and in the return value for else, but not for the if. And then I have a bug in the code and I will get wrong and unpredictable results. Therefore, R and other programming languages provide a way of controlling flow that allows us to perform repetitive tasks. And the basic idea is the following. You have a counter, so you have an integer variable that keeps track of how many times you have performed the task. So for example, in this case, we could start with a counter known as I, and we set its value to 0. And then you have a conditional statement which checks what the value of I is, and you can do one of two things depending on the value of I. If the value of I is less than the number of repetitions, in this case 5, you go and perform the task that you want to perform. So in this case, it's to print an asterisk, and you increase the counter by 1. So you change the value of I from 0 to 1, and then you go back to the conditional statement. However, and you keep doing this so long as this condition is true, so long as I is less than 5, which is the number of times you want to repeat the task. As soon as I becomes 5, right, because its value will go to 1, then 2, then 3, then 4, and finally it'll be 5, then this condition is false, and then instead of executing the statements and coming back to the condition, you pass the control of flow back to the next statement following this. And so this is the basic logic of performing repetitive tasks. And you can see in this flow chart that it looks like a loop. The path of the code follows looks like a loop, and that is why this type of flow control is known as looping. Now, the syntax in R for repeating a task a fixed number of times is as follows. You say for, and then in parentheses, you say some variable in, and then you provide a vector, and after the parentheses you give an expression, the repetitive task, and that could be a single or compound statement. And what R will do is it will have this variable take the first value of the first element of the vector and execute the expression. Then it will have this variable take the value of the second element of the vector and execute the expression, and so on until the variable takes the value of the last element of this vector and executes the expression. And after that, the control is returned to the next statement after the for statement in the code. So now let's see how we could perform this task of determining the absolute values of the vector by using a for loop instead of copying and pasting the statement repeatedly. We still need to, so we have our vec, and now we can have a much longer vector than before. So let's just say 15. This is an arbitrary thing, and we will again initialize our vector of absolute values. So we'll say vector mode is numeric, and the length is 15. We will say 4, and in the parentheses we give a vector. So let's say we want to keep track of how many times we have repeated the task. So we will say for index in, and now we need a vector of integers that goes from 1 through 15. So we can use the seek function. Remember, the seek function with just one argument generates a numeric an integer vector that starts at 1, and then the next element is 2, and so on until you reach the length of the vector. And you can also change the starting point and by how much you increment with other arguments. And then we need our statement, and even though it's a single statement, we can just use the parentheses just to make the code easier to read. And we will say if rvec index, because now when we are running the code the first time, then we want the first value of rvec and the first value of absar, and when we're running it a second time, we want the second value, and so on and so forth. And that's why we will index using this variable idx, and if it's greater than 0, then we just return rvec index, else we return -1 times rvec index. And this is our for loop, and then we can print out the results. So we can print out rvec and absar, and when we run this code, we can see it's running just fine, and all the negative values have been converted into positive values, while the positive values have not been changed. It is worth pointing out that although we are writing this for loop to illustrate how one writes for loops, if we had to actually perform this task, which is to take a numeric vector and determine the absolute values of all its elements, we wouldn't actually have to do this, because all of our functions automatically work with vector valued arguments. So R already provides a function called abs, which computes absolute values, and I could give it a scalar and it will return a scalar, but I can just give it a vector, and abs will automatically work with vectors where it will perform an element wise absolute value, and you can see the output of abs of rvec is the same as what our function does. So internally, the abs function that's built into R works the way we have written this function. So if you had to perform this task, you don't actually have to write this for loop. We are just using it for illustrative purposes. Now, one other common task that arises when you have a vector and you need to compute some scalar value from it. For example, let's say we wanted to compute the absolute values and then add them up to find the sum. So this is the kind of thing you might do if you were computing the median absolute deviation, which is the sum of the absolute values of the deviation of some statistical quantity from its median. So we no longer need a vector output, since our output is going to be the sum, and we should initialize the sum just like we initialized the random vector for the absolute values. Now we need to initialize the sum. And now when I compute my absolute value, I don't need to store it in a vector, because I'm not returning the vector, I'm just returning the sum. So at each value of this rvec, we compute the absolute value and assign it to this scalar variable absar. And now what I need to do is I need to take whatever is the current value of the sum, which when index is 1, it's going to be 0, and I need to add this absolute value of this particular element of rvec to it. And then when index is 2, our sum will be equal to the absolute value of the first element of this vector. And when we run this statement, it will become equal to the sum of the first and the second elements of rvec. And in the next iteration, it's going to become the sum of the first 3, and so on. This technique, where you take the value of a variable, add or subtract or multiply or divide something to it, and save it back in the same variable, is known as accumulation. And accumulation is a very important technique to accumulate values, and precisely what we are accumulating will depend on the situation, but in this case we are accumulating the sum, and then we can run this code and get the sum. Whatever the random vector happened to be, the sum of the absolute values is 11.279. Now, it's also instructive to see how you could do this with R functions. And R has, as we discussed, a built-in function known as abs, which will compute the absolute value of rvec. And R also provides a function known as sum, which sums all the values of a vector. And so we can call abs, and that will return a vector with the absolute values of each of the elements of rvec. And then we can take whatever abs returns and pass it to sum, which will sum it. And if our code is working right, we should be getting the same answers. And of course, in the normal course of things, we would not actually write this for loop to compute the sum of the absolute numbers. We would actually just use the built-in functions that R already provides to us. However, there will be situations where we may have to use for loops, where a built-in function is not available for the task that we want to accomplish. There is one other way we could write this for loop. So as discussed, the syntax is for variable in a vector, and here we created a vector of integers going from 1 through 15, and then our variable takes on those integer values. But given that here we don't actually need to know which position we are at, since we are only accumulating, we can actually just work directly with the elements of rvec. So I can say for rlm in rvec, which means I am going to take the first element of rvec, which will be the first random number, then do something with it. Then I'll take the second element. I won't know its position, but it doesn't matter. I can just directly use rlm. I don't need to use indexing in the vector, since we're accumulating and position is not really important. In the previous version, where we actually computed a vector, we needed to know what position we were at, so that we could assign that same position the value of the absolute value in the output. And so I can just directly iterate over the elements in this rvec and use them, and once again the result is going to be the same.